Alright guys, on this video we are going to talk about more examples on how on the application of linear approximation and the differential. Okay, so here the first example is find the figure from the figure, evaluate f 1.8. We don't know what is the function f, okay, but what we want to do is we want to use the tangent line to evaluate the height of the function at 1.8. 1.8 may be somewhere here, right? Somewhere here, right? So you want to find out the height of the function at 1.8. And also you want to find the height of the function at 2.06, somewhere here. You want to find out the height of the function as well. But we don't use the function because we don't know what the function is, right? So what we do, we use the tangent line to do that. So do you remember what is the equation of tangent line? At this point is, let's say, c f of c, then the equation of tangent line is y minus fc equals to f prime of c times x minus c. This is from the previous video, right? But also in the previous video what we did is, if you take little right or the left of c, then the equation will become, you replace y by f of c plus delta x and then x by c plus delta x, right? So we do replace y by, basically what we do is we replace y by f of c plus delta x and then x by c plus delta x, right? So if you do that here, you will get f of c plus delta x minus fc equals to f prime of c is same, and then x is replaced by c plus delta x minus c, right? Here you cancel that, c and c. What you get is, and then add f of c on both sides. Okay, I added f of c on both sides. So what I get is f c plus delta x equals to fc plus f prime of c times delta x, right? Now to find out f at 1.8, basically what is f at 1.8 is, you can write f of 1.8 as, say, f of 2 minus 0.2, right? That is 1.8. So you can take c is 2 and then delta x on this formula, okay? On this formula, this is the formula now. On this formula, you take, to find out f 1.8, I did c 2 minus 0.8 as the 1.8, okay? So what is c? C is 2 and then delta x is 0.2, okay? So f of 1.8 is basically f of 2 minus 0.2. The formula is fc is f2 plus f prime of 2. We'll find out that, and then times delta x is negative 0.2. That is f of c plus delta x. So plus delta x is negative 0.2. Okay, but how do I find out f prime of 2? F prime of 2 is basically the slope, right? Slope is m, but how do you find out m? Is rise over run, right? If you don't know the equation, if you know the equation, then you can find out f prime from the equation. But since equation is not known, you use rise over run. So from this point, I want to go to that point, right? What is the rise? Rise is, you go negative 2 unit rise. That means 2 unit below and then 4 unit right side, right? So that is, rise is negative 2, right? And then run is 4. If you simplify this, you get negative 1/2. So f prime of 2 is negative 1/2 there. So basically f2, f is f of 2 at 2, the y value is 1, right? That's why I wrote 1 here, plus f prime of 2 is negative 1/2 and then times negative 0.2. And then when you simplify this, you'll get 1.1. That is the value. Okay, next, f of 2.06 is, you can write f of 2 plus 0.06. Why did you write 2? Why didn't you write 3 minus 0.94 like that? Because I don't know what is the height of the function at 3. I know only the height of the function at 2 is 1. That's why I use 2 here. That is the reason why I did this as f of 2 minus 0.2. Because I know the 2 at 2 height of the function. I know that. That's why I use 2. Here also I use 2 because I know the height of the function at 2 is 1. That's why. So, and this is like c plus delta x, right? F of c plus delta x has fc, f2, plus f prime of c, f prime of 2, and then times delta x is 0.06. So f2 is 1, right? Plus negative 1/2 is f prime of 2. We find out that already. Times 0.06. That is delta x. When you simplify this, you get 0.97. Okay, next example is use the differential to approximate the value of 35.5. Okay, so what we do is we use the tangent line approximation using the differential. Okay, so here the problem is we don't know what is the value of the what is the function here, what is fx. We don't know fx, right? So we don't know. So what we do with this, you consider, you say fx equals to some function. Okay, what function should I take? It is like root under something. Let's say fx equals to root x. Okay, but since 35.5, root 35.5, we don't know without calculator, right? So what is the closest number of 35.5 that you know the root of? That is 36. Let's say x equals to 36, right? So I'm going to take x equals to 36, and then that 35.5, you can write, let's say 35.5 can be written as, let's say 36 minus 0.5. You can do that, right? So x is 35 and delta x is 0.5. You can do that way. See? X or c is basically 35. X or c is 35 and delta x is 0.5. So we need to evaluate f of 35.5 because fx is root x. You want to find out f of 35.5, which is same as f 36 minus 0.5. But this is like c plus delta x, where delta x is negative 0.5, right? So the formula is fc, the same formula here, right? So fc plus f prime of c times dx or delta x, you can write. It's the same thing. You can write delta x or dx. Here I use delta x, here I use dx. It's the same thing here. And then what is f of c? C is basically c is same as x equals to c, right? So 36. And what is f prime of c? To find out f prime of c, find the derivative of that. What is the derivative of f prime? Is x to the 1/2 prime, that is 1/2 x to the negative 1/2, which is at 1/2 root x, right? But at c equals to 36, f prime at c will become 1/2 root under 36, right? So that is 1/12. That's what you get. Times dx is, we have delta x negative 0.05. I plug in those values. And when I simplify, I got 6 plus 1/12, 0.05, because that is 1/12. And negative 0.05, that is product with this. So if you simplify that, you get 5.9583. But when you use calculator directly, you get 5.9582. They are almost the same. So you basically, we use the tangent line approximation to find out the value of the function at a particular point by finding the height of the tangent line at close to that particular point. Okay, guys? Thank you.